Okay. Basically, I think the classes go over Git just a little, but not really how to use it or like its true purpose. So Git is a version control software where, say, like, to pretty much you keep saving your project, and then if there is like, if something goes wrong, or if something messes up, or if like we should revert back to like a different design, then you can view all those saves, and then you can revert back to the one that you want to. So it's pretty much, it lets you like have, it's version control. So you can see like all the different steps and versions that you've made with your projects, and then just go back to it if you want to restart something or anything like that. Git is pretty much organized into like repos. Repos are just another name for like projects. But before we do anything with, and one more thing, I guess, even though it's like, Git seems like it's a software, it's more like useful for software, which is, I guess, sort of true, but yeah, but hardware teams needs to also have like, there are also versions of like hardware that you need to keep track of, and industry and companies may not use Git. They may use like their own version or a different version, but it's essentially like the same thing. So it's, and also with Git, we can keep track of like the progression of projects. And if we need to review boards, then we can review it on Git instead of having to pass around the zip file to everyone. And then, so we have a bunch of repos underneath the LHR Solar organization, and each repo is like its own separate project. All the hardware related stuff, you'll see a PCB at the end, and PCB just means printed circuit board. It's pretty much like the green board or whatever color board, like your motherboard or something like one of those circuit boards that you see, and that's what the team designs, the hardware team specifically designs. But the electronics repo, right here, this is our like overall hardware related repo. It shows like how to set up and everything like that. If you want to go back and like, if you miss something or anything like that, this repo, the README, should have everything on how to like set up and like rules and stuff like that. For the hardware team specifically, there's a extra step that other teams, other software teams may not require, and it's basically like whenever you want to copy the project or clone a project, there's these two. There are two ways to copy it or clone it. So one is with HTTPS and one is with SSH. SSH is like the more secure version of cloning and I guess pretty much accessing anything. But in order to use SSH, we have to do some extra steps. And with the way our repos are set up, with our hardware specific repos are set up, we need to use SSH. And I can explain why we need to use it in a bit whenever we start, I guess I start showing the flow of how to use Git. But first, there's like a lot of steps to getting SSH working. And I mainly want to get everyone set up on that today, so that, and it's like a one-time thing. Once you set it up, then you don't have to worry about it at all. But like pretty much getting that process done is like a steep hill. So I want to focus on that for a bit. But in that second link that I sent, the docs.github.com link, it shows you like how to generate an SSH key and stuff like that. So pretty much for SSH, it's like a secure, so pretty much you have a key, and the GitHub is like your door or your lock. You need to have a key. You need to have your own key in order to unlock and get access to all the repos and Git. If we can start getting this set up, and if anyone has any questions or or needs to or if anything weird happens, then you can just ask me. But if you want to get started on that, you can. It's just get started on typing these commands into your Git bash terminal. I already did this process, but if anyone wants to see like the process on my end first, then let me know. If not, then just let me know if you have any questions. Now, and also a quick note for the commands. The one with the dollar sign, that's and the command following afterwards, those are the commands you want to type in. So like these arrows or these hash, ignore those. And if it asks you for if it gives you a prompt, and you have to type something, I usually just press enter.
Wait, so it asks me enter file in which to save the key, so you just click enter?
Yeah, you can just press enter. If you want to change it, you can, but I don't have. I guess I'm not picky about that stuff.
Mm-hmm.
Okay, I may need to restart this process since I accidentally overwrote my keys.
Also, whenever if you guys have it set up, just do like a thumbs up, or you can post it on the chat just so we know that everyone's good. And if you have any trouble with anything, there's nothing wrong with that. Just let us know. We can even have you like share your screen so we could actually like see and help more directly that way too.
Are we supposed to type something for the passphrase?
If you want to, then go for it. But I usually don't do it. It's, I guess, right now, I guess, at least for me, these projects are like not high security. There's like nothing IP related. But if it's like, yeah, I just press enter. But if in the future, if you have like some type of like high security or your own IP related stuff that you want to keep secure, then go ahead and enter a passphrase.
The difference there with the password is if you set a password every time you use this key, you're going to have to type that in. So every time you push or pull from GitHub, if you don't set a password, then it'll be nice and seamless. But that means that if anybody else gets a hold of your file containing your key, then they'll also be able to pull and push from anything you have access to. So just choose whatever.
Oh, I had a question about the key. Is it tied to your to like your hardware, so your laptop or your desktop, or is it tied to like specific repositories?
Your computer.
Okay, so if we set it up for like embedded systems, an SSH for that, it should still work.
What do you mean by set up for embedded systems?
In embedded systems, we had to use
oh, you
GitHub
mean like 319K?
Yeah, and we ended up setting up SSH for that.
Yeah, then you should be fine.
Okay.
Dang. You guys went through that in 319K? I didn't get that.
I don't know if we were supposed to, but my lab partner ended up being familiar with GitHub, so we ended up doing that.
Okay, nice.
Yeah.
I know there's, or Clark asked me if I started and he released like a link for Git, the same one from the BPS team. Like need like catching up. Right now we're just setting up the SSH key so we can access or I guess easily access the hardware related repos.
I think I messaged the 2 people who came in privately, so hopefully they have all the links that they need. But if you guys have any questions, just let us know.
Oh, and if anyone is done and doesn't have KiCad, then maybe you got to start downloading KiCad. I sent a link.
Sijin.
Mm-hmm.
Yeah, I just woke up. Is there a BPS like meeting going on right now?
Maybe.
Oh,
I think.
okay. I can't find the link, but I don't know.
Oh,
if
it's
there's-
in the general group channel here.
Hmm. Oh, I think there is a meeting. Okay, I'm gonna go. Bye bye.
Okay. All right. See you in a bit.
Wait, how do you know what the key name is?
Key name in terms of like whenever which part of the step are you on? Like right here?
Let me see.
Oops, let me hold up, sorry. Like on this page or
I think yeah, I should be up to that page, but I don't know like where it shows the key at the bottom part.
oh this part?
Yeah.
Oh okay. So if you type in this command, then it copies it to your clipboard and then you can just do Control V inside
Oh, okay.
the box. Yeah.
Thank you.
Yeah.
Thanks, someone asked this a few minutes ago, but when I get to the pasting the key into the key field, what do I put in there?
So, oh, sorry. So this page right here, the key field.
Yeah.
Okay. On this page of adding a new SSH key, if you copy this, or if you type in this command into the terminal, then it copies it to your clipboard. So then after you run this command, you can go here and just do Control-V to paste it.
Okay.
And then give it like a unique title.
Yeah.
I think that's everyone, maybe. Shaban, are you good?
Yeah, I'm good.
Okay. Oofy. Right. I'm mainly just going to go through the flow of how to use Git now. I feel like just telling you what the commands are is sort of boring. So whenever you want to work on a board, just like go into the LH organization and then find the repo that you want to edit. So one of my tasks is to edit the telemetry board. So I'm going to get this repo cloned. So to get all the contents in a repo, you need to clone it. And cloning is pretty much just another way of saying copying the contents onto your computer. And then whenever you clone, make sure, at least for the hardware related stuff, make sure you clone with SSH, because so the reason why we did set up all that SSH key and stuff like that is in each repo, there's this like a repo inside of a repo. So this since we're linking repos, and the way we link repos is using SSH, we had to set that up. And the reason why we have a repo inside of a repo, the Git calls this submodules, and it's because there are symbols and footprints, pretty much like if symbols and footprints, Hannah will explain later, but it's pretty much there are a lot of components that all the boards, or there are a lot of the same components that a lot of the boards use, like certain standard components like connectors and stuff like that, which are common across every board. We will have to, I guess, there will be more. We will have to get the pretty much clone this repo into onto your machine as well. Like, so pretty much cloning 2 repos, and you will have to manually add these to your computer, to your KiCad project each time you want to, or each time you have to work on a board. But instead, we can we have a setup so that there are submodules, pretty much like, so pretty much it means whenever you clone this repo, you will get all the libraries and standardized footprints and symbols you need for a project. So you don't have to set up anything. So it makes everything easier. So now I'm just gonna clone it. When you're cloning it, there's this URL, and you want to copy that URL. There's this clipboard that you can just copy as well. And then, so I guess, there are certain commands that you will use extremely, super regularly. So there's cd, which is to go into a directory or folder. So right now this is what folder you're in. This shows what folder you're in. So I'm gonna just make a new directory. And if you guys want to follow along, and if there's a step that I go over too quickly, let me know. But I'm just going to make a folder real quick so that I can put the contents of this repo inside that folder. I'm just going to call it electronics. So cd is to change directory. Mkdir is to make a directory. So now if I list out all the folders, you can see that, oh gosh, there's so many. You can see there's an electronics folder that's been made now. And then I want to copy or clone this repo into that folder, so I'm going to go into it. So now you can see that it updated the path. So now inside the electronics repo, or not the electronics repo, the electronics folder, sorry, that I made. And I have a Google Doc of all the useful commands that I'm about to do. If you want to have something to reference. Sorry, I should have showed this earlier. Okay. So since this is an empty folder, when I press the ls command, which is pretty much just listing out all the contents inside that folder or the directory, you can see that since I just made it, there's nothing in it. Okay, now, sorry, I don't have chat open in case anyone has questions, but if you have anything that you want me to go over, then just let me know. But I'm going to start doing all the Git commands. So nothing is inside the folder right now. I'm going to call this git clone command. Whenever you're using Git, you need to always have the git command at the very front, git. And then there's a bunch of sub commands that Git provides. But this first command right here, pretty much if you're cloning a repo, you'll always use this command, except this link will be different. The link depends on what repo you're cloning. And then this recurse submodules option flag, this is to make sure all the submodules or all the the sub repos are pulled into your repo as well. So this just to make sure that all the standard Git symbols, but not Git, all the standard KiCad symbols and footprints are copied. So I'm just going. Gosh. And another useful thing is if you start typing in like a command or something, and if you press tab, it will autocomplete. Okay, so now I'm going to clone the repo. Then yes. If anything is, like, if I say anything that's confusing, let me know. Also, a quick note, at some point, it may be useful to clone all the repos, since I guess the Hannah's team works on like pretty much all the hardware. Yeah. Now, after it's done cloning, if you press ls again, you'll see that there's something new inside the electronics repo. So, and it's the it'll have the repo name as a directory. So I'm gonna go into that repo. So now you can see how, like, when I went into the repo, this blue text in parentheses showed up, and this shows you what branch you're in. So with Git, in order to like have multiple people work on a project, everyone should be on like separate branches. There's the main master branch, which just as a note, this GitHub is planning on changing this from master to main. So in case you see something different, that's just the one of their announcements.
And our new repositories created on our organization are already named to main.
Oh, okay. I did not know that. Sweet. All right, anyway, I lost my train of thought. Sorry. So everyone, whenever you're going to edit something, you need to go into your own branch. And this is to ensure that the main branch has like the most stable and completed version of the project. So in this case, it's the most recent board that has been made and manufactured. So before I edit anything, I'm going to create a branch, and branch just means like, you can think of it as like another copy of the main branch, or of the main, yeah, it's just another copy of the main branch. But give it something useful, or like give it a useful name. So in this case, I'm just going to say like, I'm going to fix a connector. And if you press Git branch, you can see there's a master or a main, and then the connector fix branch that I just made. And right now I'm still in the master branch or the main branch. So in order to go into that branch, you need to do git checkout connector. Now you can see that I'm in my own branch. And then let me know if some of the concepts I'm explaining is weird or confusing. I know sometimes I explain stuff really not well. Right now, I just went to the path of where the repo is in my file explorer. so that I can open up the KiCat project or KiCat project. Okay. So this is one of our boards. I don't know. This say I guess. Okay. All right. I'm just going to do like a tiny edit. I'm just going to like rename this to power connector. And CAN connector. Okay. I just edited these. I just added the names. So now, so once you change some stuff on the board inside your own branch, you can do git status, and it'll show you in red like all the stuff that you've edited. So you can see all the stuff that you've edited, but the thing is, you need to now send it to GitHub, or pretty much you need to send it to the remote server, which is pretty much just GitHub, that you've edited, you've made these changes, and that now you want to update the repo. So right now, it's something called like this is like the staging process. So you can choose which file specifically you want to add, but I usually just add all. And if you git status again, you can see that it's green, and that means that these are going to be sent to the remote server, to GitHub, so that it can be updated. And I'm going to commit this -m. This means that the message following -m will be the message, or like the description of what you did. So, and you should put something meaningful, or for actual good practice, you should put something meaningful, so that whenever we're going back, and if we want to like go back to a previous version, we know like, oh, like this commit was just changing the name, or like this commit was like editing the whole entire thing or something like that. And you should commit regularly to be like an actual like that. So committing regularly is like it should be like it is actually a requirement in most companies as well. You don't want to edit everything and just push it onto and then send it to the server. That's pretty much just defeats the purpose of Git. This is to like go back and change like little stuff, or if you want to go back and do a different go back to a different design. So I'm going to put meaningful message. So you can think of commits as like different versions, and then the message is like the description of that version. So now after you create a commit, then you need to create a commit. It like sorts it onto your computer, but the remote server, GitHub doesn't get any of that. So you have to git push. Usually, if you clone a repo, you need to set this up, or not clone repo, make a branch. Sorry. Okay. So if I do git status, it says everything, no new files has been added since your last commit. And if I go into here, you can see there's this master branch, but then there's this new branch that I made. And if I go into connector fix, you can see like the description of all the files that changed. So I changed the schematics of the board. Are there any questions? Or is there anything that I confused or not confused, I explained horribly?
So when we like make the new branches, we just use like the same one for each board we're working on, I guess. Like now that you use, or do you have to like make a new branch every time you
Yeah. So pretty much you should make a new branch whenever you're adding something significant, or if you're fixing something. It's, I guess, pretty much well, if you're going to do anything new, then make a new branch. I'm about to explain, like, say like you're done editing all the changes, now like you want to update the master branch. I'm going to explain that next, but pretty much make a branch whenever you make something new.
Okay.
Yeah, and then so once you edited everything you want to do and want to make, now you want to update the master branch. So to update the master branch, you can see right here that like if you edited your own branch, then it will have like a compare and pull request, or you can just go into here and then just make a new pull request. Just make sure you change this to your branch name. And then create. Okay. So pull request is pretty much like a review process in order to update the master branch, the most stable and up to date piece of, I guess, in this case, hardware. I usually, it's better to leave a comment or a description of what you did. But I guess this, my title is, I guess, actually, let's do this. Usually it's a good idea to put a description, because whenever you open a pull request, this is the process of how we review all the boards. So you can see right here, there are reviewers. You need to add a reviewer to the board so that they can review it and then accept all the changes and then merge all the changes into the master branch. So right now, I'm going to add Hannah as ask Hannah to review my board. I'm going to create a pull request. So whenever you make some edits and changes to your board, and you think you're good, open up a pull request, and then that's how you start the review process. And then I guess in our case, this isn't really useful. This is just like a bunch of text that isn't really meaningful to us. But if you're working on code, then you will see like all the changes that's been made. Yeah, and then if Hannah sees something wrong with the board, then she can just be like, no, this is like bad, restart or something like that.
It won't be that hard.
Okay. So usually whenever you make a pull request, it'll have like you need to have a reviewer must sign and like accept these changes. Right now it says it's like all green and says like I can merge it, but it should be Oh, there you go. The repos require you to have one reviewer approve it before you can merge it. Then Hannah just left a comment. And then if everything is good, then I merge it with master. And merging just means you're going to combine the two projects so that you can update it, or two branches. And then now the master branch, the main branch has like all the updates. So let me close this out real quick. But if I go back to the master branch, you can you'll see that all the stuff that I changed, like the names of the this connector, which was originally like CAN connector and out, and then this one was power connector. You can see that it hasn't changed, and that's because whenever you update a branch, like a remote branch, let's say like the master, then you need to your computer doesn't know that it's been updated yet, so you have to call git pull, which means it pull all the changes and update your repo, the state of your repo. So now it says that I pulled it successfully. Then when I open, oops, actually I'll do that. Now, if you see here, you can see the names changed. So now the main branch has the correct, all the changes I made in my own branch. And then once you've made all your changes, after a while, we will delete the branch that you made, since it's now like the master branch has all your changes now, so it's pretty much obsolete. So I'm just gonna delete it. And then now, if you have a new change or a new fix that you want to make, then you're going to need to make your own branch. So each branch should be independent of like what you do. I hope that answers your question on like when to make branches.
Yes, it does.
Okay, sweet. Yes, I forgot to add. Okay. Hopefully that wasn't too much. But if you have any questions, Chase, your electrical lead, or Hannah can help you out, or I can help you out if you just want to message me as well. Yeah. But all the leads are familiar and knowledgeable about Git, so you can ask them. And that's it from me. But is there anything that I explained confusingly?
Not anything. Just like I didn't actually commit any changes, and now I'm like stuck in a branch. How do I get out?
Is it okay if you share your screen real quick?
Yeah. I should make this big. Yeah. So now I'm just like, how do I I guess get out of back to the master?
Oh, git checkout. if you do git checkout master, so the third parameter in that command is pretty much the name of the branch that you want to
Okay.
go to. Yeah.
Okay. Cool.
I'm probably going to stop the recording, but if anyone has any other questions, you could go ahead.
Okay.